Welcome to day 4 of our Microsoft Azure Fundamentals training series. Today, we're tackling one of the most important architectural decisions you'll face when moving to the cloud. Should you choose IaaS, Infrastructure as a Service, or PaaS, Platform as a Service? This is a question that every cloud architect, developer, and IT professional encounters, and the answer isn't always straightforward. By the end of today's session, you'll have a clear framework for making this decision confidently for your own projects. We'll walk through real scenarios, compare costs, discuss control trade-offs, and explore when each model truly shines. Let's get started. Before we dive in, let me give you a quick overview of what we'll cover today. We'll start with a brief recap of the 3 cloud service models, IaaS, PaaS, and SaaS, to make sure we're all on the same page. Then we'll do a deep dive into IaaS, what it means to run virtual machines in Azure, how licensing works, and what level of control you get. After that, we move to PaaS, how it simplifies operations, what's managed for you, and where its limitations lie. The centerpiece of today's session is a real-world scenario. We'll take a simple web application with a database backend and build it both ways so you can see the concrete differences. We'll wrap up with a decision framework, a set of questions you can use every time to guide your IaaS versus PaaS choice, and finish with a tour of Azure's massive PaaS catalog. Let's begin. Let's quickly refresh our memory on the 3 cloud service models, because we need this foundation before we can compare IaaS and PaaS meaningfully. IaaS, Infrastructure as a Service, is the most foundational model. Microsoft provides the physical hardware, the networking, and the virtualization layer. But everything above that, the operating system, the middleware, the runtime environment, and your applications, all of that is your responsibility. Think of renting a completely bare server that you configure yourself. PaaS, Platform as a Service, goes one step further. Microsoft now also manages the operating system, the runtime, the middleware, and the platform configuration. You only bring your application code and your data. This is a significant reduction in your administrative burden. SaaS, Software as a Service, is the complete package. Microsoft builds and runs everything, including the application itself. You just subscribe and use it. Office 365 is the prime example here, running entirely in Azure data centers. Today, we're laser-focused on the middle 2, IaaS and PaaS. And we're going to understand not just what they are, but precisely when to choose one over the other. Now let's go deeper into IaaS. IaaS is often the natural first step for traditional IT professionals moving to the cloud, and for good reason. It closely mirrors what they already know from on-premises environments. When you create an Azure virtual machine, you start by selecting an image, the operating system you want. This could be Windows Server in various versions, Ubuntu Linux, Red Hat Enterprise Linux, and many others. From there, you select the size of the VM, which determines the CPU, memory, and storage capacity, and a few other parameters. Once your VM is provisioned, you connect to it and manage it just like any server you've ever administered. Want to install IaaS for web serving? Go ahead. Need a specific version of .NET Framework from 2014? Install it. Need custom firewall rules or registry settings? It's all yours. This full control does come with a cost, both figuratively and literally. On the literal side, licensing is important to understand. If your VM runs Windows Server and SQL Server, you're billed separately for each license as part of your subscription. The SQL Server license cost also varies depending on whether you choose Web, Standard, or Enterprise Edition. On the figurative side, the cost is time and expertise. Everything you'd manage on premises, you still manage here. OS patches, security updates, software installation, configuration. Azure just removes the hardware concerns. Looking at the responsibility stack on the right, everything from the operating system upward is your responsibility. Microsoft only manages the virtualization layer and the underlying physical infrastructure. Now let's look at PaaS, and the contrast with IaaS is striking. When you create a PaaS resource in Azure, the process is significantly simpler. Microsoft has already taken care of the operating system, the runtime environment, the middleware, and all platform licensing. You arrive at a fully configured, fully licensed platform ready to receive your application. The responsibility stack on the right shows this clearly. With PaaS, your responsibilities shrink to just two things: your application code and your data. Everything else, from the OS up through the runtime, is Microsoft's problem. What does this mean in practice? When a security patch needs to be applied to the underlying operating system, Azure handles it automatically. When the platform runtime needs an update, it happens without you lifting a finger. You no longer need to think about disk defragmentation, OS version compatibility, or SSL library updates. Licensing is also dramatically simplified. All licenses for the platform components are bundled into the PaaS resource price. You don't need to purchase or track separate OS or database engine licenses. The trade-off is control. You can configure certain parameters, connection pool sizes, scaling behavior, environment variables, but you cannot go below the platform layer. You can't install arbitrary software, you can't change the underlying OS, and you can't use framework versions that the platform doesn't support. For the vast majority of modern applications, these constraints are not a problem. But for legacy applications or very specific technical requirements, this can be a deal breaker. And that's exactly what we'll explore next. To make all of this concrete, let's work through a scenario that many developers and architects encounter regularly. Imagine you have a web application, a classic two-tier architecture. In the front end, you have a web application running on IaaS, Internet Information Services, Microsoft's web server. In the back end, you have a SQL Server database storing your application's data. Simple, right? Two components. Straightforward communication between them. Now the question is, do you build this with IaaS, using virtual machines, or with PaaS, using Azure's managed services? On path A, you go the IaaS route. You provision two virtual machines. One is your web server, one is your database server. On path B, you go the PaaS route. You set up an Azure App Service plan to host your web application and an Azure SQL database for your data. Let's walk through both paths in detail in the next two slides, and you'll see just how different the experience and the workload really is. Let's walk through what it actually takes to deploy our web application using IaaS. Step 1. Create your web server virtual machine. You'll go to the Azure portal, select a Windows Server 2016 image, choose a VM size appropriate for your expected traffic load, configure storage, and make some networking choices. Right away, you're paying for a Windows Server license on top of the compute cost. Step 2. Create your database server virtual machine. This is a second VM, this time with SQL Server 2016 installed on top of Windows Server 2016. Now you're paying for two Windows Server licenses and one SQL Server license. And the SQL Server cost varies significantly. Web Edition is cheapest, Standard is mid-tier, Enterprise is the full-featured but most expensive option. Step 3. Connect to your web server VM via remote desktop and set up IaaS. This means enabling the web server role in Windows, configuring your site bindings, creating application pools with the right identity, and handling SSL certificate setup. Step 4. Create your network security group rules. By default, traffic is blocked. You need to explicitly allow HTTP on port 80 and HTTPS on port 443 from the internet to reach your web server. Step 5. Configure the communication between your web server and database server. SQL Server listens on port 1433. You need to open that between your two VMs, and you want to set up proper service account for the database connection. Step 6. Deploy your application, and then recognize that you're now permanently responsible for patching the OS on both VMs, keeping SQL Server updated, managing IaaS configuration changes, and monitoring everything. That's a lot of work for what started as a simple scenario. And this is the key insight. We haven't even started on high availability, backups, or disaster recovery yet. Now let's walk the same scenario with PaaS, and you'll immediately feel the difference. Step 1. Create an app service plan. This is the compute plan that your web app will run on. You choose a pricing tier, free, shared, basic, standard, or premium, and Azure provisions the underlying infrastructure. There's no OS to configure, no web server to install. It's all there, auto-managed. Step 2. Create a web app within that plan. Choose your runtime stack: .NET, Node.js, Java, Python, PHP, Ruby, and within 2 minutes you have a live website with its own URL. No IaaS configuration. No SSL setup from scratch. Built-in HTTPS. Done. Step 3. Create an Azure SQL database. Select your pricing tier, either the DTU model for simpler workloads or the vCore model for more granular control. Set your backup retention period and click Create. The SQL Server license is included. Firewall rules for Azure services are pre-configured. Step 4. Add your connection string to your app services application settings. These are encrypted at rest and injected as environment variables into your app. No manual NSG rules between services. Step 5. Deploy your application. Azure App Service supports a rich deployment ecosystem. GitHub Actions for CI/CD, Azure DevOps pipelines, VS Code extensions, zip deploy, or classic FTP. You can even use deployment slots to do blue-green deployments with zero downtime. And that's it. 5 steps, most of which are simple form fills. And from this point forward, Microsoft handles OS patching, SQL Server updates, SSL certificate renewal, and platform scaling. Your team focuses entirely on your application. The contrast with IaaS is dramatic. Let's now put everything side by side in a clear comparison. Looking at administration, with IaaS you handle everything: OS patches, software updates, driver management. With PaaS, Microsoft handles the platform, and you only manage your application. Licensing, IaaS charges you separately for every OS and SQL Server license. PaaS bundles all of this into the resource price. No tracking, no separate purchases. Deployment speed is one of the most tangible differences. An IaaS setup for our web application scenario could take hours to a full day when you factor in all the configuration. PaaS gets you live in minutes. Cost. In most scenarios, PaaS has a lower total cost of ownership. Fewer administrative hours, bundled licensing, and more efficient auto-scaling all contribute. Control. Here, IaaS wins clearly. You can install any software, use any framework version, modify the registry, install custom certificates anywhere. PaaS is more constrained. Legacy support is a critical deciding factor. If your application needs an older version of .NET or a custom COM component or a specific version of a third-party library not supported by Azure's platform, IaaS is your only option. Scalability. PaaS has built-in auto-scaling rules that respond to traffic. IaaS scaling requires more deliberate configuration. And in the best 4 row, you can see the pattern. IaaS excel for legacy workloads, highly customized environments, and lift-and-shift migrations. PaaS excels for modern applications where you want to move fast and minimize operational burden. Now let's build a practical decision framework you can apply to any project. The key is to ask the right questions up front. Notice that the first 3 questions are all IaaS triggers, scenarios that force you toward virtual machines. And crucially, if none of these triggers apply, PaaS is almost certainly the better choice. Question 1. Do you need a framework version that PaaS doesn't support? For example, if your application was built on .NET Framework 2.0 or an old version of Java that Azure App Service no longer offers, you have no choice. IaaS it is. Question 2. Do you have legacy compatibility requirements? COM+ components, global assembly cache dependencies, custom Windows services, or special hardware drivers that need OS-level access. These push you to IaaS. Question 3. Does your application require full OS access or the ability to run background Windows services? IaaS. If none of those apply, let's look at the PaaS signals. If your application uses a modern, standard runtime, recent versions of .NET, Node, Java, Python, PaaS will handle it beautifully. If you want to minimize the licensing complexity and operational overhead we discussed in the scenario, PaaS delivers that. And if you want built-in auto-scaling that responds to traffic spikes and you never want to think about OS patches again, PaaS. The golden rule at the bottom of this slide is worth memorizing. Default to PaaS whenever possible, and switch to IaaS only when you can articulate a specific requirement that PaaS cannot meet. This approach will save your team significant time and your organization significant money. Before we wrap up, I want to give you a sense of the breadth of Azure's PaaS catalog, because the IaaS versus PaaS decision isn't just about virtual machines versus app services. PaaS in Azure spans every category of computing need. Let's do a quick tour. In the web and app category, you have app service for traditional web applications, static web apps for JAM stack frontends, API management for building and governing APIs, CDN for global content delivery, and traffic manager for routing. The data category is rich. Azure SQL Database, Cosmos DB for globally distributed NoSQL, Azure Storage, Redis Cache for in-memory caching, and Data Factory for data pipelines. Compute includes serverless options like Azure Functions, container apps for microservices, Azure Batch for large-scale parallel processing, and Logic apps for workflow automation. Messaging services include Service Bus for enterprise messaging, Event Hub for high-throughput event streaming, Event Grid for reactive architectures, and Notification Hubs for push notifications. AI and machine learning services are growing rapidly. Azure OpenAI, Cognitive Services, Azure Machine Learning, and Form Recognizer for document intelligence. In an integration, you have tools like API Gateway, Azure Synapse for analytics, and Data Lake for big data scenarios. The Azure Data Platform alone has over 50 PaaS services. New services are added every few weeks. This means the right PaaS service for your specific need almost certainly exists or is coming soon. And this abundance reinforces the value of defaulting to PaaS. You're not stuck, and the ecosystem only grows. Let's close day 4 with our 5 key takeaways. Number 1, IaaS gives you full control. When you need to run legacy applications, require custom configurations, or are migrating from on-premises using a lift and shift approach, IaaS is the right tool. Azure Virtual Machines feel familiar to traditional IT professionals and offer the same level of control they're used to. Number 2, PaaS abstracts complexity. By removing OS management, runtime administration, and licensing concerns, PaaS lets your team focus exclusively on what matters: your application and your data. It's typically faster to deploy and cheaper to run over time. Number 3, licensing is a concrete cost factor. With IaaS, a Web Plus database setup could mean 3 separate licenses, 2 for Windows Server and 1 for SQL Server, with a SQL Server cost varying by edition. With PaaS, everything is bundled. Factor this into every architecture decision. Number 4, the decision rule. Start with PaaS. Ask yourself whether PaaS can handle your requirements. Only if you can answer no to a specific, concrete requirement, such as needing an older firmware version or requiring full OS access, should you move to IaaS. Number 5, Azure's PaaS catalog is vast and growing. With over 50 data platform services alone, the right managed service for your use case almost certainly exists. Don't let unfamiliarity with the catalog push you toward IaaS by default. Thank you for your focus today. In day 5, we'll move on to Azure networking and security fundamentals. See you then.